Friends, today we are going to discuss another topic of wave optics, refraction, proved by using the HUYGEN'S principle. Now we are going to prove by using the HUYGEN'S principle, laws of refraction. Already in the previous class we discussed law of reflection by using HUYGEN'S principle. First we should know what is law of reflection. Incident ray, reflected ray and normal all lying on the same plane. The angle of incident must be equal to angle of refraction. That's the law of reflection. Law of refraction, same. The sine of the angle of incident to the sine of the angle of refraction is equal to the constant. The constant which is equal to refractive index of the second medium with respect to the first medium. The same time, incident beam, refracted beam, that's the angle of incidence, refraction, and the normal lying on the same plane. That is general definition of law of reflection, law of refraction. But now we are going to prove by using the wave theory given by the HUYGEN'S. Law of reflection, law of refraction. Previous class we discussed the law of reflection. Now I am going to discuss law of refraction. Law of refraction. Before going to study about the law of refraction, we should know what is the HUYGEN'S principle and also the wavefront. What is a wavefront? Locus of point having same state of vibration. If the wave vibrate, if all the point on the crest and the trough locus on the same point. So that is the wavefront. Locus of point having same state of vibration. See, there are three kind of wavefront. One is a plane wavefront, spherical wavefront, cylindrical wavefront. One is plane wavefront, spherical wavefront, third one is cylindrical. There are three kind of wavefront: plane wavefront, spherical wavefront and cylindrical wavefront. What is a plane wavefront? If we any sources of light coming from infinite distance, any light coming from infinite distance, so this is the source, yes, coming from the infinite source, infinite distance, the kind of wavefront is plane. This is the plane wavefront. Light coming from infinite distance or source of light kept at infinite, the name of the wavefront is called plane. So this is the plane wavefront. So plane wavefront is always a perpendicular to the direction of incident beam. Incident beam. This is a plane. Plane wavefront. Then light coming from the source, finite distance. Light coming from the source, finite distance. So this is a source of light. In the previous case, light coming from infinite distance. In this case, light coming from finite distance, particular distance. The name of the wavefront is spherical. So AB. Spherical wavefront. So the previous case, light coming from infinite distance, name of the wavefront is a plane. Light coming from finite distance, name of the wavefront is a spherical. Another one is cylindrical. See, light in the linear source of light. So this is a source, linear source of light which produce cylindrical wavefront. Cylindrical wavefront. So there are three kind of wavefront: plane wavefront, spherical wavefront and cylindrical wavefront. Light coming from the source, infinite distance, the form plane. Light coming from the source, finite distance, the form spherical. Linear source of light which produces cylindrical wavefront. So these are the three kind of wavefront. By using the wavefront, Huygens proved law of reflection as well as law of refraction. Law of reflection as well as law of refraction. According to what is the Huygens principle? According to the Huygens principle, each and every point on the wavefront considered to be the sources of secondary wavelet. According to the Huygens, each and every point on the wavefront considered to be sources of secondary wavelet, which is spread out same medium with the speed of light. So every point produce secondary wavelet to the speed of light in the same medium. So this is the secondary wavelet. Each and every point on the wavefront considered to be the sources of secondary wavelet, which is spread out same medium with the speed of light. Same medium. The given medium, the speed of light 3 in 10 power 8 meter per second. Same 3 in 10 power 8 meter per second spread out. If suppose in the medium, the velocity changes. So velocity changes, the wavelength of the secondary wavelet also changes. So according to the Huygens principle, each and every point of the wavefront considered to be the source of secondary wavelet with spread out same medium with the speed of light. The forward envelope of all, this is forward envelope of all secondary wavelet. So according to the Huygens, each and every point on the wavefront considered to be the source of secondary wavelet, which is spread out the same medium with the speed of light. The forward envelope is secondary wavelet. Forward envelope is a secondary wavelet. See how this plane wavefronts obey law of refraction. Now let's discuss. See, let's consider one of the wavefront. There are three kind of wavefront. Plane wavefront, spherical wavefront and cylindrical wavefront. It is better to take light coming from the source infinite distance. Okay, see, this is XY refracting surface. Refracting surface, not reflecting surface. Refracting surface. If it is a refracting surface, the surface which separates between the two media. One is a rarer medium, another one is a denser medium. Let us consider this is a rarer medium. Suppose rarer medium air. This is a denser medium. It may be the glass or water. So XY is the surface, plane surface, which separates between two media. X, Y, not reflecting surface. If it is a reflecting surface, light has to be reflected in the same media. Light has to be refracted through other media. So you take another medium, either glass or water, any one of the medium, where the light travels with velocity lesser. See, according to the Huygens principle, already we proved by wave theory. Wave theory given by the Huygens. According to the wave theory, light travels from rarer medium to denser medium. Velocity of light lesser than the rare. If velocity of light in air medium 3 in 10 power 8 meter per second. Velocity of light in denser medium not equal to 3 in 10 power 8 meter per second, lesser than 3 in 10 power 8 meter per second. So according to the wave theory, light travels lesser in denser medium than rarer medium. Always maximum speed of light only the rarer medium. If light entered any medium not equal to 3 in 10 power 8 meter per second, lesser than 3 in 10 power 8 meter per second, the speed depending upon the refractive index. Speed depending upon refractive index. Let us consider speed of light in rarer medium is V1. V1, 1 represents a rarer medium, 2 represents denser medium. So velocity of light in denser medium. So these are all denser medium. Velocity of light in denser medium lesser than the velocity light in rarer medium. So V1 always greater than V2. So velocity of light denser medium always lesser than the velocity light in rarer medium. So maximum only at rarer medium. Okay. Let's consider light coming from infinite source. Light coming from infinite source. Suppose P and Q. P, Q are the rays coming from infinite distance. If light coming from infinite distance, what kind of the wavefront is possible? Only the plane wavefront. Plane wavefront is a possible light coming from infinite distance. So what kind of the wavefront? So this is plane. Plane wavefront. So this is A, this is the B. So these are the wavefront. Each and every point of the wavefront according to the HUYGEN'S principle spread out speed of light in the same medium. One of the wavefront incident on the refracting surface at a point A. So at a point A the wavefront incident. So AB is plane wavefront. Plane wavefront. After incident of what happened? This is denser mediums or rarer medium. This is a denser medium. After incident, refract, not travel in a straight line. Bends towards normal. So draw normal. This is a n. It is a n prime. Similarly here also, draw normal. N prime. What is a normal? Normal that should be perpendicular to the surface. So xy, the refracting surface, n prime normal. Normal to be drawn at a point xy, perpendicular to the xy. So n prime represents a normal drawn. So it is imaginary. See, after incident at the point A, light has to be travel towards normal, not in a straight line. So towards normal. So this is angle of refraction. This is angle of incidence. Similarly, after in this point, refraction towards normal, this is the angle of refraction, this is the angle of incidence. Similarly, number of rays coming from infinite source, inside the plane, here also, on refraction towards another medium, but bends towards the normal, not away from the normal. If light travels from denser medium to rarer medium, light has to be deviated. That means away from the normal. But light travels from rarer medium to denser medium, bends towards the normal. So the angle between normal and refracted ray, angle of, that is refracted angle. Angle between incident and normal, angle of incidence. But our aim to calculate, prove, this wavefront must obey law of refraction by using the HUYGEN'S principle. We know that this is the ordinary light coming from the source, incident on the surface which obey, but this wavefront must obey law of refraction. Law of refraction. Okay. According to the HUYGEN, each and every point on the wavefront, this is the wavefront. AB is the wavefront. Each and every point on the wavefront considered to be the sources of secondary wavelength. Sources of secondary wavelength. But at a point, now take two extreme points, A and B, the light incident to point A and the same wavefront incident to point B. According to the HUYGEN, the point, one of the point at point B travel, which emit secondary wavelength, the certain distance. After 1 second, the emit secondary wavelength meets here. After 2 seconds, meets here. After 3 seconds, meets here. After n time, t interval of time, meets at this point. Meet this point. After t interval of time, the secondary wavelength from the B meets at a point in this. Suppose you put point C, the point C. But already we studied, light travel from the rarer medium to denser medium, velocity decreases. If velocity decreases, not travel the same length as like in air. Light travel from the secondary wavelength is travel from B to C, but the given by the time the secondary wavelengths start from B, so reaches a point C. The same time the secondary wavelength from A would have traveled same distance of C, BC, but not in the denser medium. Not in the denser medium. But BC is a distance, not same distance to travel inside the medium because velocity lesser. Velocity of light in denser medium lesser, not equal to BC, lesser than the BC. Lesser than BC. Suppose at A is the center. A is the center. Another one more thing. If the light secondary wavelength start from B to C, the time taken, the same time the light, the secondary wavelength travel in a denser medium. the given interval of time. In 10 seconds, light travel from B to C. Same 10 seconds, light secondary wavelet start from B to certain distance not equal to BC. Not equal to BC. So that may be certain point. So the secondary wavelets form like this. Suppose the secondary wavelet from B to C meet at a point C. Same, the secondary wavelet from this point meet here. After incident refractor, put R mark. Similarly, secondary wavelet from A travel in a denser medium in not equal to BC, lesser than the BC. So you put arc here. Similarly, any secondary wavelet between B and A and B, incident between A and C, refracted and moving. So these are the tangent. Join the tangent between C and one more point. This is the D. This is the D. See, BC is not equal to AD. See the distance. The given interval of 10 seconds, the secondary wavelet start from B to C. Same say 10 seconds. Secondary wavelet would have traveled from A to D, but length is not equal to BC. So lesser than BC because of light travels in denser medium. The speed is always lesser than the rare medium. Lesser than rare medium. The tangent, this is a forward envelope of all secondary wavelet which is refracted between A and C, not only extreme point A and C, A and B, all the point between A and B travel and incident, strike on A and C is a refracted surface after refraction. So, after refraction meet at a point. So, this is a tangent of all the secondary wavelet. So, this is a forward envelope of all the secondary wavelet, that is a CD. AB, plane wavefront. Plane wavefront. CD, refracted wavefront. Wavefront, it is an incident. It is a refraction. So this is the incident wavefront in air. After incident, all the secondary wavelet travel certain distance between A and C. After refraction, meet at a point between C and D. So CD is a refractive wavefront. If it is, see, AB incident on the surface, angle of incidence I. Angle of, see, PA incident on the refracting surface which makes an angle I. So the I is angle of incidence for the ray. So this side represents angle of incident for the plane wavefront. Angle of incidence for the plane wavefront. If it is I, this is R. This is R. Angle of refraction. So CD makes an angle R with respect to XY. AB makes an angle with respect to XY. So AB makes an angle I with respect to XY. CD makes an angle R with respect to XY. So I represents angle of incidence. Here the R represents angle of refraction. So this is the incident wavefront, refracted wavefront. Whereas this is the incident ray. This is PA incident ray, AD refracted ray, AB incident wavefront, CD refracted wavefront. Refracted wavefront. We know that light travels from B to C, the same interval of time, same 10 seconds, light travel from B to A to D, but distance only change. BC is not equal to AD. BC not equal to AD. But time taken from B to C, same interval of time. Suppose the light secondary wavelet start from B to C, it takes 10 seconds. 10 seconds, light traveled from A to D, but distance is lesser. Distance is lesser. How to calculate that? Here the time interval is the same. Time same. T same. Okay. Now calculate the time. Velocity is equal to displacement by time. We know that formula. Velocity is equal to displacement by time. But time, T is equal to S by V. T is equal to S by V. See what is the time taken from B to C? T in error medium. That is T1 is equal to S. Displacement BC. Velocity V1. In rarer medium, velocity V1. In this T2, time taken from A to T2. T2 is equal to, what is the distance? AD distance. AD distance. What is the velocity? V represents velocity. Velocity denser medium is V2. But T1 and T2 is equal. T1 which is equal to T2. Light travel from B to C, same time light travel from A to T. So T1 is equal to T2. What is the T1? BC. BC by V1 is equal to AD by V2. AD by V2. Now rearrange. V1 by V2. BC by AD. V represents velocity in rarer medium. 2 represents, V2 represents velocity in a denser medium. But our motto is to prove law of refraction using the Huygens principle. So we calculated time. V1 by time same, but V1 by V2 is equal to BC by AD. BC by AD. But according to the law of refraction, sine of the angle of incident to the sine of the angle of refraction must equal to refract index of the second medium with respect to the first medium. So refract index of the first medium may be N1, here N2. So N1 represents a refractive index. N1 refractive index is a rarer medium. N2 refractive index and denser medium. So sin I by sin R is equal to N21. N21. Now we are going to prove angle of incident, incident beam, refracted beam, and normal lying on the same point according to the law of refraction. But according to the law of refraction, by using the Huygens principle, incident wavefront, refracted wavefront, and normal lying on the same plane. Normal lying on the same plane. Okay. Now calculate I and R. How this I is equal to this I? How this R is equal to this R? So the angle of incident ray, which is equal to refracted wavefront, reflected wavefront, incident wavefront. The R represents, this R represents refracted wavefront. This R represents refracted ray. This R must equal to this R. This I must equal to this I. How? See, in this angle PAN, the angle PAN is equal to I. So this I, this angle, this is I. What is I? Angle I is equal to PAN. I which is equal to PAN. This PAN which is equal to this I. How to correlate? This is fully 90. Angle between the angle normal and the surface 90. So this is equal to PAN. PAN is equal to 90 minus NAB. If 90 minus NAB remaining BAC. So this is equal to 90 minus this fully 90 minus NAB, subtract NAB, which is equal to BAC. So this I is equal to this I. So this I, angle of incidence I, which is equal to PAN. So this PAN which is equal to, this full part is 90. 90 minus NAB, subtract. If 90 minus NAB remaining, BAC angle. BAC angle. Similarly, angle of refraction R. This R should correlate with this R, equal to this R. So this R, N prime AD. N prime AD, which is equal to, again 90 minus this full part 90. The angle is 90. 90 minus N prime AD. So N prime AD, angle of incident, angle of refraction. Angle of refraction. N prime AD, this R. So 90 minus, we have to correlate this one. 90 minus ABC. This is angle of refracted wavefront. So this angle is fully 90. So N prime AD. N prime AD is equal to this fully 90 minus DAC. DAC. Fully 90 DAC. If DAC, if subtract from this 90, ACD. remaining ACD. So this I which is equal to this R. Sorry, this R is equal to this R. This I is equal to this I. So this I, angle of incident ray which is equal to refracted wave, incident wavefront. Refracted wavefront which is equal to refracted ray. So I and R correlated. Angle of incidence, ray, angle of incident wavefront. This is the refracted ray, this is a refracted wavefront. We correlate I and R. Okay. According to the law, sine of the angle of incident to the sine of the angle of refraction must equal to refracted at the second medium with respect to the first medium. Okay. Sine I calculated sine. Now, in this right angle, there are two right angle triangles. So this is right angle, this is right angle. ADC, one of the right angle. ABC, another right angle. In the right angle, ABC, right angle triangle ABC, sine I. Sine I. What is a sine angle? Sine angle is always equal to opposite divided by hypotenuse. Opposite divided by hypotenuse. So this is I. What is opposite? BC. Hypotenuse for this AC. For the right angle triangle ABC. Similarly, right angle triangle ACD. ACD. Sine R. Sine R. This is R. We know that angle of sine opposite divided by hypotenuse. Opposite. For this opposite AD. AD. Hypotenuse for this angle AC. Sine A calculated. Sine R calculated. But according to this Snell's law, angle of incident, sine of the angle of incident to the sine of the angle of refraction. Snell's law, sine of the angle of incident to the sine of the angle of refraction is equal to refract index of second medium with respect to the first medium. Here, N21 is equal to sine I by sine R. Sine A by sine R. What is a sine I? BC by AC. This is BC by AC. Sine R, AD by AC. AD by AC. So, N2 divided by N1. This could be written as N2 by N1. So, sine I by sine R. BC by AC, AD by AC. So, AC cancel. So, remaining BC by AD. Come here. BC by AD. What is the BC by AD? BC by AD is equal to V2 by V1 by V2. So, N2 by N1 is equal to sine I by sine R is equal to V1 by V2. BC by AD is equal to V1 by V2. That means refract index of the second medium with respect to the first medium is equal to V1 by V2. V1 by V2. According to Snell's law, we proved. So the sin A by sin R is equal to V1 by V2. Sin A by sin R is equal to N2 by N1. N2 by N1 is equal to V1 by V2. V1 by V2. We know that time taken from the wavefront B to C, where the reach at point C is equal to A to D. The same interval of time. That means time interval same, the frequency remain constant. Light travel from rarer medium to denser medium. If light travels from rarer to denser, wavelength lambda change, velocity change, frequency no change. Light travel from rarer medium to denser medium, its velocity changes. That means velocity decreases. Wavelength changes. How the wavelength changes now we are going to prove. And the frequency remain constant. Frequency depending upon the time. Nu is equal to 1 by t. If the t remains same, if the t same, frequency same. The frequency of rare medium to denser medium same. Similarly, light travels from denser medium to rare medium. Again the frequency remain constant. If wherever light travels from one medium to another medium, always the frequency remain constant. Keep in our mind. frequency remain always a constant. Wavelength change, velocity change. Okay, now come to the point. N2 by N1 is equal to V1 by V2. N2 by N1 is equal to V1 by V2. So sin I by sin R is equal to V1 by V2 proved. We know that by using the formula V is equal to N lambda, or V is equal to nu lambda. Nu represents the frequency. This is the formula to calculate relationship between velocity, frequency and wavelength. So V is nu lambda 1. 1 represents wavelength in rarer medium. Again, nu lambda 2, because the nu remain constant. Frequency remain constant. Frequency remain constant. So nu cancel. So sin I by sin R is equal to V1 by V2 lambda 1 by lambda 2. Lambda 1 by lambda 2. So V proportional to lambda. Where the velocity greater, the wavelength is also greater. Where the velocity lesser, wavelength is also lesser. In this case, in rarer medium, according to the wave theory, velocity is greater than the denser medium. If light travel from rarer medium to denser medium, velocity decreases. Velocity of light decreases. If velocity of light decreases, what about the wavelength? Wavelength is also decreases. So wherever the light travels from one medium to another medium, what suppose a light travels from rarer medium to denser medium, air medium to the glass or air medium to denser medium, wavelength decreases, velocity decreases, but the frequency remains constant. Same time, light travels from denser medium to rarer medium, wavelength increase, velocity increase, but the frequency remain constant. Wherever the light travels, keep in our mind, always the frequency remain constant. Wavelength, velocity varies. Wavelength, velocity varies. So far we studied the refraction, the light from one medium to another medium by using the HUYGEN'S principle. So not only the law of reflection, prove the law of reflection, law of ordinary, law of reflection, law of refraction, we already studied. By how the law of reflection, law of reflection, law of refraction obey by using the HUYGEN'S principle. According to the HUYGEN, each and every point on the wavefront considered to be the source of secondary wavelet is spread out, same medium with the speed of light, which also obey law of refraction, also law of reflection. Law of reflection. By using HUYGEN'S principle, law of refraction, we proved the sine of the angle of incident to the sine of the angle of refraction is equal to the constant. That is, refractiveness of the second medium with respect to the first medium is also equal to V1 by V2, also equal to lambda 1 divided by lambda 2. 1 represents a rarer medium, 2 represents a denser medium. So V1 proportional to lambda. So V1 proportional to lambda 1, V2 proportional to lambda 2. So generally, velocity proportional to lambda, but the frequency remain constant. So we'll discuss some other topic next class. Thank you.